SpaceX said on Monday that it had successfully put 51 more Starlink satellites into orbit on its 40th mission of the year. The Falcon 9 rocket that put 51 Starlink satellites and Spaceflight's Sherpa-LTC into orbit took off from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. Stay with us till the end to find out every detail about SpaceX's 40th launch of the year. The Falcon 9 took off from SpaceX's Cape Canaveral Space Station pad LC-40 at 10:09 p.m. EDT on Sunday, September the 4th. The rocket booster and fairing that had been used before, as well as a new upward stage, worked as expected, keeping the Falcon 9's record-setting streak of 149 successful launches going. After only 31 days, the former Falcon Heavy B1052 booster flew for the 7th time and worked perfectly. It landed on the deck of an unmanned SpaceX Just Read the Introduction ship a few hundred miles away, less than 9 minutes after launch. When going up, the random halves of the Starlink 420 Falcon 9 mission, which flew for the 4th and 5th time, also worked as expected. SpaceX isn't talking about fairing recovery, but after re-entering Earth's atmosphere, both halves probably opened their parafoils and landed gently in the Atlantic Ocean. At some point, the SpaceX support ship Doug will pull them out of the water so they can be used again. Starlink 420 was the 6th SpaceX Starlink flight, as well as a Starlink mission. At the top of the stack of 51 Starlink V1.5 satellites was a Spaceflight Inc.-built experimental spacecraft. As part of a project called Sherpa-LTC-2, Spaceflight and its partner, Astro Digital, turned a space tug into a satellite for Boeing. The goal is to carry and test a communications payload prototype made by Astro Digital. This will help test new V-band communication technologies that Boeing wants to use for a planned group of satellites in low Earth orbit. In November 2021, the US FCC approved plans by Boeing for a group of 147 V-band satellites. It is not clear what this group will do or if Boeing already has customers or business partners. The future of the constellation will largely depend on the prototype spacecraft created by Spaceflight and Astro Digital, known as Varuna, in recent FCC filings. Boeing wants to use a part of the electromagnetic spectrum called the V-band, which has a higher frequency than the Ku and Ka bands that most other communication satellites use. Higher frequencies can mean faster connection speeds and more bandwidth, but rain and other bad weather can make it hard for V-band radio waves to get through. Varuna should help Boeing figure out for sure if this interference is a problem or can be worked around. In 2017, Boeing asked the FCC for a license for its V-band constellation. It's not clear if the process took so long because Boeing wasn't interested or because there were problems with the bid. A little less than 50 minutes later, the Falcon 9 successfully sent Varuna into a mostly circular orbit 316 kilometers above the Earth's surface. The Sherpa-LTC-2 should eventually reach a working orbit of about 1,050 kilometers, where a V-band payload can be tested at the same altitude as the planned Boeing constellation. This will be made possible by a propulsion system made by the start of Benchmark Space. 20 minutes after Varuna was sent into space, the upper stage of the Falcon 9 turned from side to side and fired all 51 Starlink satellites at the same time. This finished the payload part of the mission. As usual, the upward stage is likely to deorbit within a few hours of launch and should re-enter the Earth's atmosphere soon after. This will make sure that the only space junk from the mission will be the Varuna deployment mechanism and a set of 4 safe Starlinks. The return of the tension rods is expected in about 2 months. While in space, Varuna will try to confirm the assumptions about how the V-band spectrum works. This will let the markers of the terminal equipment and other hardware that works with Boeing's V-band non-geostationary fixed satellite service show how well their design works. Also, the satellite will give potential commercial and government users of Boeing's broadband communication services a chance to test how well V-band communications links work for certain applications. This mission's first stage booster, B1052-7, has helped send Arabsat 6A, STP-2, Cosmos Skymed's second generation FM-2, KPLO, and 2 Starlink missions into space before. This booster was flown again after its previous mission, KPLO, which took 31 days. At T-38 minutes, SpaceX's launch director gives the go-ahead for propellant loading. This is the first step in the automated launch sequence. Both stages were filled with subcooled RP-1 kerosene at T-35 minutes, and the first stage was filled with liquid oxygen. At T-20 minutes, the second stage of the RP-1 was fully loaded, and a large vent was seen coming from the transport erector. This is done to clean the lines of RP-1 in preparation for the second stage's upcoming phase of fueling, which started at T-16 minutes with the loading of LOX. After the LOX was loaded, the RP-1 of the first stage and the LOX on both stages were filled to the top until T-90 seconds. At T-7 minutes, the first stage of the Falcon 9 started to chill its engines. To do this, the booster sent a small amount of LOX through the oxygen section of each M1D turbopump. This kept the propellant from turning into a gas when the engine started, which could cause a lot of damage. Then at T-1 minute, the countdown was taken over by the flight computer, which did the last pre-launch checks. At the same time, the propellant tanks were filled with air to match the pressures needed during flight. This is when the call, "Tanks are pressed for flight," was made. Next, at T-45 seconds, the launch director made sure that everything was ready to go for launch. The engine controller then sent the order to start the engine at T-3 seconds. At T-0.02 seconds, the engines and vehicle were running normally, and the vehicle told the hydraulic launch clamps to release at T0, which let the vehicle rise. At T+1 minute and 12 seconds after liftoff, the vehicle reached max Q, which is the moment of the most aerodynamic pressure. The Merlin 1D engines on the first stage stayed on until T+2 minutes and 29 seconds, when a series of events happened in quick succession. First, all 9 M1D engines shut down, and then the stages started to move away from each other. The single M1D vacuum engine on the second stage was then turned on. At T+3 minutes and 13 seconds, the fairings, which protect the payloads during ascent from debris and heat from the atmosphere, came off the vehicle. Both pieces use RCS thrusters and parachutes to get back into the atmosphere and land gently in the Atlantic Ocean. SpaceX's fairing recovery ship, Dogue, will then bring back the 2 halves of the fairing. Also, after the stages separated, the first stage spread out its 4 grid fins and used its thrusters to get itself in the right position for re-entry. At T+6 minutes and 5 seconds, the first stage started its re-entry burn, which lasted 31 seconds before the engines shut down. The first stage then slowly drifted back toward Earth, using its grid fins to keep it going in the right direction. At T+8 minutes and 5 seconds, the first stage fired up again to slow it down for a soft landing on SpaceX's autonomous spaceport drone ship. Just read the instructions. Once the second stage got to the normal parking orbit, the second engine was cut off, and the stage went into a coast phase for just over 37 minutes. The MVAC engine was turned back on for a 2-second burn, which raised the orbit so that the payload could be released. The Sherpa-LTC vehicle was sent out from the top of the Starlink satellite stack at T+49 minutes and 28 seconds. The second stage then started to rotate around its x-axis. At T+1 hour, 12 minutes and 23 seconds, the 2 tension rods were released. Due to the stage's rotation, each of the 51 Starlink satellites has a different amount of angular momentum. When the tension rods are released, this causes the satellites to move apart. The Starlink satellite will now spend the next few months moving up to Starlink Shell 4, which is a circular orbit at 53.2 degrees and 540 kilometers in diameter. At least 3 more Starlink missions are planned for SpaceX, and the TTL mission is set for September. So that's all for today's video. If you like this video, give it a thumbs up, and if you want to watch more videos like this one, hit the subscribe button and turn on notifications so that you will always be notified.